Okay. Okay, so the link I hope you guys have seen. If you're still joining, so I do encourage you, particularly if you have two screens, it is probably very easy. That way you can put my thing in one screen and you can work in the another screen. Okay. Okay. So if you create your account in this site, then you can store the programs. So I have already logged in here. So let me see whether how it looks like if you are not logged in. Use another editor. Yeah, see, so it's kind of like a white background and all that. That's how it starts. So you can sign up pretty easy. I think you can just click on sign up and create an account. Okay. Okay. So let's see. Meetup today. What we are going to cover. So, interestingly, today also it's raining. So can you mute, please? Mute yourself. Thank you. So, few days ago, last week or 3 weeks ago, when it was raining, I looked up the top glass of the car, and all this raindrops. It looked very nice. So nature's pattern, right? So I thought, how closely we can draw using this p5js. It's very creative coding website. So it's very, few of you might have done maybe Khan Academy JavaScript or something. So I thought, we will do a session based on p5js and try to do our best. Okay, so can you post few comments? What do you understand from this picture? Some characteristics. Can I get some, in the interest of kind of understanding, probably better if you can post in a chat instead of speaking. That way others also kind of can see a summary. Each raindrop looks unique. That's true. Yeah, each raindrop does look unique, makes it a bit complicated, right? Any other observations? Any other observations? Thanks, Trey. Any other observations about this raindrops? The thicker outer line around the drops. In fact, if I can expand that, thicker outer, yeah, some places seem to have very thicker, but that may be to do with actually photograph maybe. But anyway, the bigger the drops seem to be thicker outline, isn't it? Looks like that way, right? I mean, that seems very sophisticated. See, the tiny ones, the lines are smaller. Maybe that's because they're bigger or whatever. That's it's very interesting. The lines seem to be thicker. Spacing between raindrops is not really even. Yeah, that's right. And Maria, thank you. They are generally circular in nature. Little bit of kind of ellipse, kind of not so ellipse, that type of thing, right? It's amazing to look at how many properties are there, right? Okay, so the question is how close we can come. So we are going to start with really simple and see how far we can go. Okay. I can tell you this. I don't. Today's my intention is not to generate exactly that. That's not my intention. But we'll see how close we can come with the reasonable complexity. Okay. Okay. So this p5js website, editor.p5js, that's the link I had posted. I'll post once more for people who join late. So if you want to kind of play along and do it, you're welcome to do so. So pretty simple interface. Code is left side, right side is this output. You got to play button. If you play, see that's a canvas area, which is 400. There are a few things you can do. Let's see, window width. See, by the way, see, this is running and it's a check mark, so it just keeps running all the time. So I don't even need to say anything. Window height, instead of 400, now it's using pretty much the remaining space. I think if I change this, if I make this smaller, it will probably go back and run everything. No, let's see. Yeah, I guess I have to rerun it again, I guess. See, so it just occupies the remaining space. That's very nice, isn't it? It's automatically kind of runs and we do want a big canvas area, right? As much as possible, we want a big area. Okay, I hope you guys can see my code here. Let's see whether I can, do I need to do anything? Maybe I can do some setup and change the font size a little bit. Give me a second, that way you can see better. You don't need to do that, but I will do it so that you can see better. Yeah, I will do under the settings, there is a text size. Okay, so a little bit bigger. Okay, and okay, so let's play with this little bit. So this is a JavaScript code and there's a create canvas, that's creating canvas here. And this p5js interestingly kind of behaves like Python a little bit. You don't need semicolon, hooray. Escape from semicolons, like all other languages need. So what's going on here? Setup, create canvas, this area, and there's a background, and there's a setup function and draw function. Draw function draws again and again. Kind of doesn't make sense to do the background here. Let's remove the background here and let's put the background here in the setup itself. Now, when it comes to draw, this is a one-time thing. Okay, in the draw, we can do whatever we want. Let's see. There are two functions. By the way, I know it may look like I'm pulling the functions out of thin air. If you go to this site, reference, p5js reference, you can see the big library things. So maybe we should just quickly run over that, right? So bunch of inbuilt function. That's what their current software is, right? More and more stuff pre-built makes it so much easier to do the fancy things very quickly, right? So if you kind of go through this reference here, you can do a lot of work with colors. Fill is something we will use. And right here is a circle, ellipse. Very important, right? Circle, we will start with circles. So you can see all this nice drawing functions. I won't use all of them. I don't even know all of them. Okay, so see, window with window height. Right there is a display with the display height. We'll see that soon. Okay. So you can see that's JavaScript kind of tying to the browser, I believe. Transformations, all kind of stuff. It's a humongous number of functions. Key pressed and mouse based even. We'll get to that soon. So anyway, you see the thing. So anytime any function, if you want to kind of look for more information, you can do that. Okay. So fill basically is fill color, selecting the color. Let's not do that right now. We'll come to that. Let's do the circle. Okay. We want a circle. And what was that picture again? Let's go to this, put the picture here. Looks like a background is a little bit light. Well, even outside and inside is same color, right? That's kind of interesting. But again, we don't need to perfectly follow that, but we'll do that anyway for now. Okay. So I am going to say no fill. There's no change for fill color basically. Okay. So circle, let me say 200, 210. Let's see whether it draws anything. There you go. That's our tiny circle. We can change that to 25, little bit bigger. See, right? 200. By the way, I got to explain the coordinate system. The coordinate system is 0, 0. It's kind of upside down first quadrant of the graph. Okay. So usually, I know you guys draw, school students, you're used to the graph sheet, first quadrant, right? Like this, first quadrant, second, third, fourth, so on, right? So this is like a first quadrant, but upside down. Okay. So that's a 0, 0. Not, this is not 0, 0. So 0, 0. This is a width comma 0. This is the 0 comma height, and this is a this is the width and height. Okay. Okay. So we are drawing at 200, 200, this 25. That's just one circle. We want to draw a lot more, right? So a lot more and distributed way, right? Let's do that. Let's do distribute. Instead of two fixed value, I say random width anywhere along the x-axis, any place random. This one will be random height. So this draw function gets invoked again and again and again. See, that's the beauty of this p5js and similar website, that you can write so limited code. Boom, you can kind of get amazing things you can do, right? We are just getting started. There are some obvious problems here. Compare this with that raindrops. What are the obvious problems? Obvious things you see. By the way, I'm going to save this program several versions. That way you will have access. You can, I will send you the link where you can access those. We will call it lot of circles, right? Lots of circle. Yeah, whatever. So I'm going to kind of send you that link to save. Yeah. And let me find that link. So this is the place you can find all my programs. Okay, I'm going to posting the link as well. So back to the editor. So by the way, a few more, I kind of jumped in and didn't explain fully. The background, when you say the one number, that's a grayscale number. See, background, if I say 0, that's a black background. Okay. So 255 is pure white background. Okay. Let's do a little bit darker shade. Yeah. Trying to match with that. This one. Okay. If you want a little bit thicker line, you can do that. Stroke weight should give you the little bit thicker line. See that? Double thickness. This is actually a good time for me to explain one more thing. See, one other thing about drawing is we really want as big canvas area as possible. How about if I can use the whole screen as the canvas area to look more dramatic, isn't it? So this one is that. So let's see. Instead of window, how about I use the whole display? Okay. Immediately you see the scroll bar appearing, and we do need to make this go full screen. So we need a mechanism to make it full screen. Let's see, mouse clicked. See whether we can do that. Mouse clicked, full screen, I think. I'm going to click here. Let's see what happens. There you go. The reason why I still have this scroll bar appearing is that because I am escaping, because I think I have 110% zooming. I'm going to reduce zoom little bit, see whether, I guess we can run, let's see, click. Yeah, see, when it's 100% perfect thing, it occupies the whole screen. So that's the display with the display height. But the problem with this screen, I cannot see the code. See, now you can wow at your creation, but you're not able to see the screen, right? So we escape. When you escape, it comes back to the screen. And I can continue to work on this code. So you can put this full screen true right here in the setup, but then it will be bad. You cannot reach out to the code, you know. So then you cannot do auto refresh. Okay. So a few things I have to kind of work around that. So let's see. I can remove this and then put the full screen true. Then it will automatically go to full screen. When you finish, escape. Program will stop running basically. Okay. So whereas now I can click on it to go to full screen, escape, I can come back to this writing code, this screen. Okay. Let me change some more, because I do have a lot of space. I can just use the bigger font. Okay. Any questions so far? I can explain. So one of the thing you see is that always it's 25 size, right? How about we randomize that as well? Let's do random 10, 100, let's say. Looks more of a circle-based art rather than raindrops, right? Looks nice too. There are few things are easier to accomplish, and a few other things are a lot harder to accomplish. Okay, so one other thing, remember the stroke weight seem to increase with the size, right? So let's try to see whether we can accomplish that, right? Let's see how we can make the stroke weight, the line thickness, proportional to the circle's diameter. Well, this is the diameter, isn't it? So let's see, diameter equal to this value, right? Diameter. So instead, I'm going to use this variable there, and then let's make that stroke weight based on diameter. Obviously, you don't want to say diameter, that would be too thick. That looks very weird. Let's see, how much should it be? At the minimum should be 1, right? 1 plus diameter by 100. It's a good start. You can see the bigger ones are a little bit thicker, you know. So if you want some more emphasis, you want to do maybe diameter by 50. That looks better, isn't it? The tiny ones are a little bit thinner. See, that comes kind of very close to that raindrop thing. See here, see, The tiny ones are kind of thin lines, bigger ones are a lot thicker lines. So next biggest thing we need to do, this is the version 2, right? Let's do the version 2 here. And save. Okay. And when I click on it to go full screen. I'd like to kind of answer a few questions, anything based on what I wrote. Again, if I can do a quick run through, that's a setup function. That's basically saying that the canvas area is display with display height, the whole screen, okay? And the background is kind of gray and no fill, basically, since no, if I don't have this no fill, it's going to be by default to be white fill. See that? By default, it fills the white color. Okay. So that's why I have no fill. We can look at some variations later. Okay. No problem. So this one is to kind of go full screen. To go full screen, right? Mouse click to, if I click once, I click here, it goes full screen. See, right? So then draw gets invoked again and again. So every time the draw is system automatically invokes the draw. Okay, it randomly selects a diameter and it decide the stroke weight, the line weight, line thickness. That's what the stroke weight is. I guess that's an artistic term, you know. If you're an artist, you know it's a stroke, right? Stroke weight, I guess it's an artist term. So kind of proportional to diameter, and then we go ahead and draw the circle in the random place. Okay, that's what the code is. Any questions so far? Next thing I want to work on is avoid drawing on each other. Okay, we can never have the raindrops like this, isn't it? Okay, that's one. Another one is little bit of ellipse will be nice, isn't it? Ellipse. Actually, ellipse may be a little bit easier than the other one. I'm just debating which one to do. Let's go. Let's go ellipse. Okay. Okay. So how do we do ellipse? Instead of circle, you go ellipse and diameter, and one of them can be a little bit smaller. Let's say if I put the one of them little bit smaller, let's say 0.8 or something. Let's see. See, now you see the ellipses. The only problem is that all the ellipses look exactly kind of like a lengthwise ellipse. It's not kind of odd ellipses. They all look the same shape, right? So some randomness will be nice, right? And also, even with that, it may look like this, or it may look like tall ellipse, or kind of like a flat ellipse, right? What about some ellipse in kind of random angles, right? So those are a bit of challenges, right? We have. So what we can do is, first of all, this one also randomize a little bit. Let's say random. When you say random and two numbers, that's a range. Whereas random one number, it automatically assumes minimum is 0. Okay. So now I randomized the how much the ellipse flatness basically, right? See, now you look at it, some are, see, this one is almost like a circle, whereas some are quite flat. See, So it's quite a few different shapes. That's because the height I randomized. Okay. Still, the ellipse kind of looks always x-axis, y-axis. Kind of looks still pretty uh, pretty much without turns, right? So how do we do that? How can we kind of turn the ellipse, right? Okay, so we want to turn the ellipse. So whatever we are drawing, we want to kind of give a random turn. For that, we need to invoke something called transformations. Translate. What you do is you go to a random place, okay? You go to a random position and then give you a rotation, random rotation, then draw the ellipse. Give a random rotation. I believe I can say angle mode degrees. Otherwise, it's a radians. So rotate random. How much should we? 90 degrees. Will that do? Or 180? Probably 180 may be overkill, but now you see that interesting shape ellipses. See? Yeah. Okay, so that's not terrible. I'm going to save this version. This is a lot of. Again, you should be able to access all the programs using this link. Okay. Okay, so back to editor. So now the biggest work is to avoid. How do we avoid overlapping, right? You cannot have a raindrops like this, so that's what it's showing here. How do we avoid that? Any thoughts how we can avoid raindrops touching each other or overlapping? Simple answer is not easy. You need to know what is already there, isn't it? You need to know all the raindrops that are already there to ensure that we don't overlap with that raindrop, right? So logic is going to be, let's write down some logic here. So you can select a random place. Before you draw the raindrop, we want to see whether that random place selected is already part of the raindrop, right? If it's already part of the raindrop, you're doomed. You cannot draw anything there. You just give up, right? If not, then you have to see how big that raindrop can be. See, let's try again. See, right now, if I'm drawing here, I can draw a big raindrop. But if I'm pretty close to this, right, then I cannot draw a exactly really big raindrop. Yeah, size is limited, isn't it? Okay, so we need to remember all the, so what are the steps we need to do? Remember all previous raindrop positions, not only position, diameters too. You need to remember the diameters. That way you want to see how far that raindrop comes, right? For each new raindrop, right? Each new raindrop, what do we need to check? Check whether the position is already inside a raindrop, then it's no good, right? If not, right, then decide the diameter, reduce the diameter as needed, right? Reduce the diameter if needed. This is called pseudocode, by the way, to ensure to avoid overlap, right? Okay, so that's the logic. Okay. Let's see the draw here. I don't know if I can draw here. I'm going to try x position, yeah, x array, y array, diameters, right? X position, Y position, and diameters. Basically, that's how we are remembering. These are the arrays we are going to use to remember. Okay. So after doing this, now that we have an arrays, these three arrays we are defined, diameter is there. We want to remember, and X and Y right here. See. Okay. So right here, we want to say X position. This is a new one. I'll use a variable called X position. Random width Y position equal to random height. And then now we can use X position, Y position. Okay, and the diameter is there too. So after drawing, we want to save all of them. Okay, x dot push X position, Y dot push Y position, and diameters dot push diameter. Finally, we have achieved storing this data. Okay. Let's see whether I can do something just to give you an idea. Print X, will it work? See, X array alone I'm printing as we draw. And I can see the array keeps expanding. Stop. Let's draw again. Whoa. I was hoping to see some small array first. I guess it runs very fast, maybe. Wow. Maybe I should put it inside. Let me try that. So hoping to see, maybe it's printing too much very fast. You know what? Instead of printing all this, let me print the length. X dot length. How many items? Let's see. No. I think it's just the length. Okay, you can see it is going up very fast. That's why. Even printing may not be perfect. Anyway, you hopefully get an idea. So I'm going to remove that. I'm going to clear. Okay, reduce. So, okay, now we managed to store in the array, but we haven't used it. See, remember all the previous positions, right? But before we draw, before we take this step, right? See, this step, we need to implement that. We need to implement whether this raindrop is inside the inside the existing raindrop or something, right? So how are we going to do that? You pretty much have to check against all previous raindrops, right? So you have n raindrops. I think I should go. Let me try this one. Hopefully you guys can see it. Okay. So you have a raindrop here. Let's say you have a raindrop here, raindrop here. Okay. Okay, there are enough raindrops. So now, so there are a few cases that we have to work on. So now the new position, so let's say random position you come up with, let's say is here, the new position. That's a bad one to draw. We cannot draw, right? You how much ever small because it's already part of the raindrop. Okay. So that's no good. Once you figure that out, it's inside. By the way, for our checking purpose, we are going to assume they're all circles. Okay, not ellipse is a lot harder to figure out whether inside outside. So maybe that's an exercise for you guys. If you are very thrilled about, you can try that. I'm going to keep it simple. So consider as if it's a circle and see whether it's inside. Okay. Okay, so then next thing is once it's out, actually we'll find out quickly that they're all kind of intertwined. So once you have somewhere here, let's say this is the random point. Now we know that this circle is the closest to one, this ellipse. So our maximum is we are going to give some buffer, right? We don't want to touch the existing raindrop, right? So we want to maximum is give some buffer. Our maximum size is, I went too far. So our maximum size we should limit to that, right? Something like that. That's the idea. Okay, so how are we going to do that? Okay. So every time, so in your loop, we are going to check, how far is the distance to the center of the center of that circle or distance to the edge of the circle, so on. Okay. Okay. Let's go back to code. For loop. Before drawing, I think I just say equal to 0. You don't need to, in a JavaScript, this environment, you don't need to specify a type. You can start using it automatically. X.length I++. For each circle, we are going to, each ellipse, we are going to check, right? So we want to compute the distance to the so we're going to compute the distance to the edge of that circle. Okay, so first thing we need to do is distance to that circle, right? So distance between that's the end of circle, is center of that circle and this circle, right? How do we do that? Distance equal to dist of x. Dist is an existing function. You can check again if you go here. Should be able to search right here, distance you can specify x1, y1, x2, y2, you can find the distance. Okay. Okay. So that's what I'm going to use. X position, y position, x of I, y of I. That is the distance between the current position that you want to, maybe you can say new x, isn't it? How about that? New x sounds better. New x, new y. This should be new x and new y as well. And this one should be new x, new y as well. Okay. So here also, new x, new. What's the distance between our new position and the existing raindrop position, right? You find the distance. Now, that is distance to the center, right? But what about distance to the edge? Distance to edge would be distance minus diameters of I. Diameters are the radius. Should be radius, isn't it? So you're probably actually better off remembering the radius instead of diameter. Should we change everything to radius? Yeah, that will be good. Let me simplify things a little bit. So what we can do ellipse mode radius. Now, yeah, radius. Okay, we'll just leave the variable name as a radius here. We have to say probably here new radius, right? Let's go to new radius, and yeah, that way it's a bit easier. Radius of I, and where is it here? New radius, right? New radius, new radius, new radius, radius. Okay, so this radius, ellipse mode radius means instead of diameter, I am specifying the half the length. You know, that's what it is. You may be wondering, hey, how does the ellipse and radius work? Well, ellipse has kind of like two radius, radius 1, radius 2, right? So okay, so now hopefully this is clear. Let's see, you're computing. Hopefully it's still working. No. Where is that? New radius, new radius. No, we didn't do anything else. Should work. Auto refresh. Okay. Draw. New radius. Okay. This one, basically it should be half of that. That's not a big here. I don't know, I'm surprised that it didn't say a compline. Okay, right here is a compline. You know, I didn't see diameter, right? That's why. Yeah, there you go. Should probably save it. That way you guys have an option. So data ellipses. It's kind of intermediate version. V2. Okay. Okay, so now let's continue the logic. So distance to the edge is there. Interestingly, if you are inside, let's say this point, right? Inside, if you look at it, distance to the edge will be negative, okay? Because center point, distance to the edge is, let's assume this is the distance to its diameter, it's a radius, right? And distance to this point is smaller than the radius. See that? So, which means this minus this will result in negative value. If it results in negative value, that means its point is inside. Okay. So So if this is smaller than this, that means you're inside, isn't it? So if distance to edge is less than 0, return. Return from the function. This return will make you return from the function because we are no good. We don't want to draw that. Okay. And surprise till it's there. So I was hoping not to see any overlap. Oh, because you're not using the new values. Okay, now I know why. Okay, so distance to the edge. If this distance to the edge is bigger than this new radius, the new radius has to come down. Okay. If distance to the edge is bigger than that radius we wanted to draw, is that correct? Or small? Should be small. If the distance to the edge is smaller than, this is the radius that you want to draw, but there's a circle raindrop nearby at this distance. If that is smaller than that, then you want to avoid the overlap. So you say new radius equal to distance to the edge. Now this will result in touching circles. See, some places it may result in little bit touching. Finally, overlap is gone. Okay. Surprise, this is a thing. Okay. You know what? The stroke weight should be in the bottom because the new radius keeps changing. So you should say, stroke weight should be decided after the new radius updates. Okay. And hopefully see now smaller ones are kind of tiny lines, bigger ones. So one more change is that you do want to reduce the need give some buffer right after. You give some buffer, maybe 5 or something. May result in negative, or no, it shouldn't result in negative, but that may be well, you can also do this. If new radius is less than maybe 10, return. Don't draw, basically. There you go. Okay. Or you can simply check for negative values too. That's another way. You can do the minus. So we want to do this that way. We won't touch the nearby raindrops. Then if this is too tiny, yeah, there you go. I think that's a nice sweet spot. We should have ellipses. We should have ellipses that are not touching each other. Kind of looks like raindrops. What does a new mean? This new x, new y, new radius, that's the raindrop we are going to draw, basically. That's what this is, okay? Values for the new raindrop that we want to add. So we are determining the position where we want to add raindrop, and this is the size we want to add, but we need to validate this. Is it safe to draw? Right? Initially it will be safe to draw because you don't have anything going on. But as time goes on, you have a lot of raindrops already there. You have to be careful, right? You cannot draw inside the raindrop. You cannot draw too big near the near your existing raindrops, so on. Does that make sense? Actually, it looks pretty impressive. So you can see the kind of spacing everywhere. So as time goes on, obviously the raindrops are going to be only tiny because you don't have much space, right? I am happy with this, and we are also kind of getting to 1 hour mark. Save it. So let's go. That raindrops. This one, right? That's pretty good. Raindrops. Now let's kick it up notch and do something totally different. Okay, totally different. Use colors basically. Okay, let's see. Save it and duplicate. What I would like to do is go ahead and use a fill color. Okay, and use the kind of white background. And before drawing, I want to do a fill color. Fill random 255, random 255, random 255. Ready? Instead of raindrops, it's kind of like candies or whatever you can think of. You know, bit too colorful, of course. So the fill, the 3 parameters, that's basically RGB. Okay, red, green, blue. Okay, you can specify the parameters. So kind of look nice. Okay. I am saving this. Lots of colorful raindrops. Okay. And you should be able to see everything, by the way. All my code is all the program versions are here. Now I am going to open it up to questions. I try hard not to go over 1 hour. Okay, that's around 45 lines of code, 40 or so. Just to kind of high level the arrays thingy. So here's a empty arrays. So here you're adding to the array. You know, every time when you draw, you're adding to the array. So initially it's empty, no, nothing in array. And then first raindrop is added, second raindrop is added. So that's how the arrays keeps growing. Dynamically, they keep growing. So here, this what it means is that the for loop, you're checking for all each existing circle. That's what this I is. See, I is the index value. See that, right? So you have so you have we have X array and then Y array and the distance array, like that, right? X, Y, not distance array, the radius array, right? So you have this first one. This is index 0, index 1, index 2, so on, right? So let's say you have 10 10 circles already, right? 10, right? So then the index will be 0 to 9. It will go. X dot length is 10, right? So so then to compare against all existing, the circles information, then finally, then once this new circle is added, you simply do the push, right? I won't worry about the colors. So push, so the array keeps expanding, right? So let's go to the code again. So in the for loop is basically, there's a question asking when does the loop start? You mean, are you talking about this draw? Draw doesn't stop at all. I mean, that's a way you can count or something. You can stop maybe at some point if you want to. Yeah, this is a kind of like infinitely, it just keeps invoking this draw. Okay. This loop, for loop, is obviously checking against every existing circle, right? So for every existing circle, we'll compute the distance. The distance is compute the distance to the edge. This is the distance to the center. Then we compute the distance to the edge of that circle, right? Edge of that raindrop, right? We are kind of approximating because that's the ellipse thing, but the ellipse itself is inside the bigger circle. See that? We are, you can see this, for example, this ellipse, right? See, we are not drawing anything inside this circle. See that? That's one approximation I have done, because it's very hard to figure out this point is outside and this point is inside, so on. So we are kind of approximating to that circle. So that's one of the reasons some places you won't see, seem to be a lot of gap, so this is a good example, so even here. Okay. So if the distance to the edge is small, then we go ahead and update the new radius. We make the new raindrop size also smaller. And this you need to give some spacing, additional spacing, right? Additional space, give some space. This thing, and give some space to neighbor raindrop, don't touch it, right? Because so you can see it can do a lot of powerful things here. So based on this latest, by the way, anywhere you can say return. Return means it just returns out of the function. It won't do proceed any further down. Okay. So if the raindrop is already inside another raindrop, the proposed raindrop inside another existing raindrop, we return. Similarly, if the new raindrop is very tiny, or too close to the edge, maybe right outside, then we return 2. Otherwise, we go ahead and come up with a new radius, the stroke weight. Then we go ahead and do this random rotation business and draw a ellipse, and then we store this new position, x position, y position, new radius in the array. Okay. That way we can use it for future raindrops. Whew, I am done. You guys can ask me questions. Please ask. Otherwise it becomes just looks like a YouTube video, so. How do you control the size? Are you talking about raindrop size? Right here, we decided to max it out at 50. Instead, you can do 200. There you go. See? So I had specified the maximum raindrop size. Looks interesting, isn't it? That's a one huge raindrop. Does that make sense? Okay. So right here is the how small it can be, how big it can be. That's I guess small doesn't really matter because we're kind of controlling here. But we don't want to start out with the too small, I guess. You can also start with a little bit bigger, I guess, right? If you start out too small, maybe this is too small. Maybe you can start out bigger. So that way, initially you won't have really big, really small, tiny ones, I guess. Then over time, it does become tiny because of the neighbors. So initially your size is limited only by this. See, initially your size of the raindrop is decided by that because you don't have many raindrops. But once you have bunch of raindrops, this one will be reduced by this. Please explain how you decide the number 5 for addition 5. Just pure guesswork, really. I didn't do anything. If you want more spacing, see, I thought 5 will be good enough, So if you want even more spacing, you can put 10, So I just simply approximated. That's all it is. Anand, are you talking about 4 or 5 predetermined sizes? Is that what you're referring to? That way, yeah, you can do that. You can have maybe even array of sizes, and then you kind of dial down in that sizes. Certainly, you can do that. Yeah. But I don't know that nature does that way. Nature is not that way. So, but you can certainly try that. Even this raindrops, you can limit to a fixed number of colors, for example. Okay. So we really love this environment. By the way, this p5js or Khan Academy JavaScript. Khan Academy JavaScript, compared to that, this one is full screen. I love full screen. So you see that effect of our circular check. See this one, we check whether this circular area, no raindrop comes. That's why you have this empty space. So if we improve our check, the ellipse check, instead of circle check, if we make it a ellipse check, then you can avoid the spacing. See. Thank you so much for coming. Okay. Any other questions? By the way, we do have a spring break coding camps. I think one coding camp is creative coding with the p5js. That one we will use this website to teach. Okay. And so I'm going to kind of post that links to. Let's see here. That's our UTD spring break camps. So this is the spring break camps. And then our summer camp, just today I published the schedule, summer camp schedule. One, and the camp that will corresponds to this one is, that one is Khan Academy. That one, creative coding with JavaScript, we will use p5js. Okay. And we also have the free after school coding clubs. So I know I went just boom, okay, went very fast, right? In right here, see, February 6th, 1 hour at 11 a.m. Okay, every Saturday starting February 6th. Okay. So let's see. That's the link. Thank you so much for joining. I'll be here for some more time. Feel free to ask any questions.